Hello everyone, welcome to my channel. In this video, I'll explain you about how to find the maximum resultant stress on the fillet well along the vertical plane. So here the given question is, a 16 mm thick gusset plate is connected to the 12 mm thick flange plate of an I section using fillet weld on both sides. So this is one side and this back side is another side, that is two sides. So here the gusset plate is subjected to a point load which is 350 kilonewtons acting at a distance of 100 mm from the flange plate. So size of this fillet weld is 10 mm and depth of this welding is 500 mm. So for this I am referring IS 800 2007 code book. So here code book states that specify that the formula for the fillet welds. This is page number 80 and clause number 10.5.10. The fillet welds, that is Fc equal to root over Fa square by Fa square plus 3q square in IS 800 2007. The same clause I mentioned here. So I wrote the formula. So here we have to find Fa and Q. These two are the unknowns. So this is the normal stress formula. And first I am going to find Q value. We know that Q is nothing but shear stress due to shear force or tension. Here he mentioned shear force due to tension. So we know that shear force formula, load by area or shear force by shear area. That is, load is nothing but this one 350 and kilonewtons, that's why I wrote it as 1000. And next area is nothing but L into B, this rectangular portion area. So L into B nothing but 10 into 500 mm. But here I wrote 2 is nothing but two sides we are doing the welding. This is one side and this back side is another side. So that's why I wrote 2. 50 Newton per, I got 50 Newton per mm square. And next unknown is Fa. So Fa is nothing but normal stress, compression or tension due to axial force or bending moment. So we know that bending moment formula, that is Z equal to I by Y max for the rectangular portion. So I is nothing but moment of inertia BD cube by 12 and Y max is nothing but for example this is rectangle and this is the neutral axis. From here to here it is Y max. For example this total is D and here to here Y max, that is D by 2, nothing but B or D. Okay, D by 2. So I wrote it the same formula, I equal to BD cube by 12 and Y max equal to B by 2 from neutral axis to from here. So 12 gets cancelled in two tables 6 times and this D gets cancelled in this cube 2 times. So ultimately BD square by 6 is the formula. So we know that moment equal to force into perpendicular distance, Fa equal to normal stress, that is PE by Z is the formula. So P means nothing but load and E means nothing but perpendicular distance, force into perpendicular distance. 350 into 1000, that is kilonewtons, into 1000 is the perpendicular distance for this load. Force is this side and perpendicular distance is this side. And next B into D square by 6. So here T is nothing but throat thickness of this weld. So code is specifying in page number 78, clause number 10.5.3.1 about the throat thickness. See here, effective throat thickness. So we have to consider this effective throat thickness of the fillet weld, that is 0.7 times of T, thickness of the thinner plate. Okay, so that's why I am choosing this 0.7 into 10. 10 is nothing but thickness of this plate. So 0.7 into 10, that equal to 7 mm. And here 2 is nothing but, for the effective length, code is specifying that the effective length also we have to consider. For this, code is specifying 10.5.4.1, so we have to consider 2 times. Length of the weld is made of the effective length shown in drawing plus 2 times the weld size, but not less than the 4 times of the weld size. So that's why I multiplied it with 2. So 2 into t into d square by 6, b into d square by 6, that is the formula. So z is nothing but b into d square by 6. So I substituted all these values in this equation. So I got 350 into 1000 into 100 by 2 into 7 into 500 into 500 by 6. So I got 60 Newton per mm square. So I substituted these two values 50 and 60 in this equation. 60 square plus 3 into q value is 50 square. So I got Fc value, that is nothing but maximum resultant stress is 105.35 megapascals or Newton per mm square. So I hope you like my video. Thank you so much. Thanks for watching my videos. If you have any doubts, please mention in the comment section.